So good evening everybody. So this is unit 1 LCS, and the problem is find the overall gain of C of S divided by R of S for the signal flow graph shown in the diagram. So a signal flow graph is given, that is the input is R of S, the output is C of S, and it has few loops, 1 2 3 4 5 loops. So we have to find the transfer function of this, and also find the Mason's gain of this problem. So first, the solution first one is we have to find out the number of paths in the problem. So it has two paths. The one is the path is going from R of S, G of 1, G of 2, G of 3 till C of S. So we have uh, kept R of S G1 till G4 and C of S. So the gain of the forward path P1, that is equal to G1, G2, G3 and G4, and one more path is there. So you can see the R of S is the gain is going here. From here it goes towards the output C of S. So R of S G1, G2, and from here it goes to output. So R of S G1, G2, G6, this G6, the gain 6, and it goes to C of S. So the gain of the path 2 is P2, that is equal to G1, G2, and G6. So this is a step 1. So on the step 2, next step we have to identify the number of paths in the loop. So the first loop is this one. So here it is between 2 and 3. So you can see the loop is 2 and 3, and it has a gain G2, and it has a feedback of minus H2. So it is denoted as P11, and the value of gain and the feedback is minus G2 into H2. Similarly, in the next loop, that is loop between the 2 and 4, and it is indicated as 2 and 4, and you can see here the loop between 2 and 4 has two gains G2 and G4 and minus H1. You can see it here also. So G2, G3 and minus H1, we can indicate this as P21, that is equal to minus G2, G3, H1. This minus goes here. So again then loop 3, and here loop 3 it has only one gain, that is starts in node 4 and ends in node 4, which is we denoted as P31, and it has one gain, that is G5. The next loop is between 3 and 5. Between 3 and 5 there is two gains, that is G3 and G4, and minus H3 is there. So it is indicated P41 minus G3 and G4, and there is another loop which is between 2, 3 and 5. So in that we have you can see here 2, 3 and 5. So it has gain 2 and gain 3. Gain 2 and gain 3. So we indicated this as P51, that is equal to minus G2, G3 and H2. So this is step 2, and after this one we have to identify if there is any loops that is touching, any two loops that is touching and sorry, non-touching. So you can see here this loop between 2 and 3, and this individual loop is non-touching. Remaining all loops are touches each other. So this loop and this loop, so we are indicating this as P12, that is equal to minus S2, that is this loop and this gain plus this individual. We have to multiply those two loops, and the P12, that is equal to minus G2 G5 into H2. And again we have to check whether any other loops, any other three loops is touching is there, and there is no three loops touching, so we have to leave it there. So this one and this one, and two more loops are non-touching, which is this one and also this one. So you can see here this loop and this loop, these two are non-touching, so we have to put this as P22, that is we have to multiply these values, that is minus G2 G6 into H3, the minus goes in the front. Similarly just G5, so the value is minus G G5 G6 H3. So after this we have to calculate the delta and delta K. So for this we have to sum of the individual loop gain plus sum of the two non-touching loops. So these are the value we have identified, and this is the formula. Delta is equal to 1 minus P1 1 plus P21 plus P31 plus P41 P45 plus P12 plus P22. So we have to substitute all the values, and we'll get the delta's value, which is 1 plus G2 H2 plus G2 G3 H1 minus G5 G2 G3 G4 H3 plus G2 G6 H3 minus G2 G3 H2 minus G2 G3 G6 and GH3. So this is the value. So after this we have to check one more thing. So in first forward path we have to find which loop is non-touching, since all the forward paths the loops are touching where the delta is indicated as 1. Since this one all the loops in the forward path is non-touching, so we are indicating this delta 1 as 1, and for the delta 2 we have to find which loop is non-touching, so we have to have the delta 2 as 1 minus GS. So in forward path there is it's also forward, there is no touching loop, so delta 1 is equal to 1, and in forward path 2 it has indicated 1 minus GS. So both the delta and delta 2 value 1 minus GS is here. So finally the transfer function. So the transfer function formula T is equal to 1 divided by delta summation K and Pk and delta K. This is Mason's gain formula, and for the and this is 1 by delta P1 delta 1 plus P2 delta 2. This is for the first forward path, and this is for the second forward path, and we have to equate all the data into this Mason's gain formula, that is T is equal to G1 G2 G3 G4 into 1 plus G1 G2 G6 1 minus GS divided by 1 plus G2 plus H2 plus G2 G3 H1 minus GS plus G2 G3 G4 H3 plus G2 G6 H3 minus G2 G5 H2 minus G2 3 G6. So this is the final answer. Thank you.